Alright, in this video, what we're going to be talking about is how to interpret change in exponential models. So here's our function right here. It says after the last ice age began, the number of animal species in Australia changed rapidly. So this relationship right here is that basically it looks like it's going to be a decaying factor because it's going down over time. So what we're going to have to do here is simply figure out like what's the decay rate, how much is it losing, and we're going to type in our answer. So this is in the form, I'm just going to change s of t to y equals, all right, in the form of a times b to the power of x, where a is your initial, all right, so our a value is represented by the 4.2 million, and our b value is represented by the 0.72. So our a value, I'm just going to put 4.2 million. There we go. And our b value is this decay factor known as 0.72. All right, so if that's 0.72, that means it's going down over and over and over again. It's basically you're keeping 72%. If you're keeping 72% of the animals, what are you actually losing? That's what you're trying to ask yourself. So if I have 100% of my animals, but I'm losing, all right, I'm keeping 72%. That means I'm losing 28%. All right, so that's something you need to be aware of is right now it says every single year 28% of the species are being subtracted from the total number of animal species. So just remember, when you're dealing with exponential functions, you're always starting with 100%, and you're either adding to it or you're subtracting from it. In this particular case, we were subtracting 72% from it. All right, that's right. We're subtracting 28% from it, but we're keeping 72%. So this right here, this would be our b value. Now this is called, just remember, this is called a decay factor. All right, so right here, every year we are 28% is being subtracted from the total number of animal species. Okay, now I'm going to go ahead and start this one over again real quick and take a look at the next problem. Okay, so right here we have something that's growing, and how do we know that it's growing? Because this number is greater than 1. Just remember, when you're interpreting things, this right here, that's your a value, that's your b value. We can clearly see that the b value is equal to 1.85. If you multiply anything by 1.85, it's going to be growing, okay? And that literally is the factor that you're going to be using. So right now, unfortunately, locusts happen, all right? And this right now, it looks like we're modeling the number of locusts that are increasing every single day. Holy cow, that's not good. That's a lot of locusts, all right? If you like locusts, read the Bible. If you don't like locusts, then don't want to read like in Genesis. It's pretty bad. I mean, you should still read it, but just locusts are bad in Genesis. Egyptians really don't like locusts. Okay, so we're going to say they grow. The locusts are growing, all right? And then every single day by a factor of 1.85. Ooh. Okay, now here we have a percentage, okay? So here's we have a percentage, and I am not even going to attempt to pronounce, we'll just call him or her Q. All right, we'll just call him Q. Invested some money in a bank account. The relationship between the elapsed time, t in months, since Q invested the money, and the total amount of money is this. So fortunately, it looks like they're gaining 2%. All right, not a whole lot. Okay, all right, but if it's 1.02, what percentage is 1.02? 1.02 is a percentage of what? 102%. But what do you start out with? You start out with 100%, and what's being added to 100? Just 2%. So right now, every single month, right here it says T is month, so every single month, 2% of the money is being added to the total amount of money in the account. Now before, what did we do? We didn't add, we did what? We took it away right here. If you look over here, we took away that 72%. That means we were losing 28%. But here, we're just adding 2%. Okay, so 2% is being added to. They're not making a whole bunch of money, but it's better than nothing. All right, right here, looks like we got something growing. What's our growth factor? Our growth factor is 2. All right, so we're going to say it grows by a factor of 2. That's how easy it is. All right, right now, we're only keeping 96%. Okay, so if we're only keeping 96%, how much are we losing? Every day something's being losing. What are we losing? 4% is being subtracted from the total mass. So this is this part is really easy. It just helps you understand, hopefully, over time, like, what does that mean? That means, what are you keeping? You're keeping 96%. That means you have to be losing 4%. Okay? So by the way, this is one of the greatest things that, like, casinos, when they advertise, they say 98% winners. Okay? Well, guess what? If only 98% of the people win something of the time, that's how they make their money. Because, you know what? If I had a certain amount of money and I kept multiplying it by 96% over and over and over again, this is going down. So that's how they get you. All right, 4% is being subtracted from. That's all you got to do. Okay. Now the next one's going to be a little bit more difficult. It's not that actually, it's not that bad. Okay. But what we're going to be talking about now is what's called interpret time in exponential models. So what you're going to want to do is you're going to write this right here. All right, and we are going to write this guy right here in our journal. All right, we're going to write that guy down. Interpreting time. Now, does everybody see the factor here, the b factor? Our b factor is 1 over 8. Well, if our b factor is 1 over 8, what is it losing? It's losing 7 over 8 because it's keeping. By the way, this means it keeps 1/8 of the total. It keeps 1/8 of this, but it's losing 7/8 of this. But there's something new, everybody. Something new. This right here. Okay? So what I'd like you to do right now in your journals, I want you to write this down. We're going to talk about what the heck does it mean to have a fraction. So what we're going to do is we're going to rewrite this. Not 1. We put t over 2.05. But I want to write it down more than once because I want you guys to see the difference here, okay? What if I put t over 16? I got to put 1/8 right there. All right, we'll do one more. Hopefully by the third one it'll make sense. 1/8 to the power of t over, let's just do 52. Why not? Let's do 52. All right, so right now, if you would, please, go ahead and write these down in your journal. All right, so students sometimes would get confused about the sample loses what? 7/8 of its mass every certain amount of months. Well, if it keeps 1/8, that means it's losing 7/8. Now, before this right here, we didn't have that. What did we just have? Just a t. So basically, every single month, it would lose 7/8 and keep 1/8. But now we have a fraction. So what number would you have to put in for t for this to equal a 1? What number would you have to plug in? 2.05. So literally, it loses 7/8 of its mass every 2.05 months. So the number that you'd have to plug in is literally, to get it equal to a 1, would be 2.05. Well, how long would I have to wait on this one? I'd have to wait a total of 16 months. How many months would I have to wait on this guy? A total of 52. So understand, this controls how many months, or the time that it would take before you would have to lose 7/8 or keep 1/8 of this. So yes, this particular one is going to be ridiculously easy, okay? So this one's going to be 2.05 months. Right now, if you look at this, right now it's quadrupling. It's a factor of 4. It's not every minute. How many minutes will it take before you can multiply this sucker by a factor of 4? What number would I have to plug in there? A total of 10.5. It takes 10.5 minutes before this becomes 4 to the power of 1. So if you're kind of confused of what's happening, I'm just going to do one more thing. If I have 5 times 4 to the power of 10.5 over 10.5, so if I plug in 10.5 right there, that becomes 5 times 4 to the power of 1. So now it goes from 5 all the way up to 20. So it quadruples not every minute, but every 10.5 minutes. Okay? So right here, it's losing 50% because it's keeping 50%, so it's losing 50%. Keeps 50%, loses 50% every 4.3 seconds. So yes, those are pretty easy. Those aren't going to take long. So guys, the hardest one is dealing with this thing called construction. So this is the one we're going to spend the most time on today. You should have 2 easy hundreds and one that you actually have to spend a little bit of time. So here's what I need you guys to write down. And you can substitute her name for any name that you want. Just don't name your kid Cheppy. Unless it's just a family name and you're respecting somebody, okay? So guys, would you please write this one down in your journal, take your time, make it nice, make it neat. All right, so here we go. We have Cheppy is an ecologist who studies the change in the narwhal population. I love Mr. Narwhal from Elf. Of the Arctic Ocean over time. I'll be watching Elf over and over again. Yes, I do own it. It is on my Amazon Prime, and I can watch as many times as I want. So do not be a cotton-headed ninnymuggins over the holidays. All right, so she observed that the population loses 5.6% of its size every 2.8 months. The population of narwhals, how sad, can be modeled by this function. So here we go. We have n of t. What we're going to do start out putting y equals. Ready? Y equals a times b to the power of x. We're just going to start with that basic understanding, okay? However, I'm going to scroll down just a bit. We do know our a value. Our a value is what we're starting with. So how many narwhals are we starting with in the Arctic Ocean? 89,000, okay? Now this is the part where you have to pay very close attention. What are we losing? We're losing 5.6%. So if you would, please put, we're losing 5.6%. Now that decimal is 0.056. But if you're losing 0.056, that means you're actually keeping something. So we actually have to do 1 minus that. Because we're basically taking 100%, and what are we taking away? 5.6%. And so what is that going to leave us when we do 1 minus 0.056? What do we keep? 94.4%. So if we're losing this, what population are we keeping? We're keeping 94.4%, and that decimal is 0.944. That's the important number because that literally is your decay factor. That's the factor for B. So when I'm typing this in, sorry, for those of you who are still copying it down. As I'm typing this in, I need you guys to understand that it would be absolutely wrong to follow the 89,000 and you put 0.056. That would be bad. What does that mean? That means we're only keeping 5.6%. And what are we losing? Whew, that amount. We're not losing that amount. How much are we losing? That'd be horrible. That'd mean all the Mr. Narwhals would be gone really quickly. We're keeping what? 0.944. But it doesn't lose it every single month. So like right here, this time right here, we're not gonna say it loses it every single month, because t equals months. It loses it every what? Every 2.8. So if it loses it every 2.8 months, that's where you have to make that little fraction bar up here. And you got to put t over 2.8. And this is our final answer for that word problem. Okay? So I wanted you to write all the words down so you understand how to take, if you lose something, you got to take it away from what? You got to take it away from 100% to see what percentage you still are able to keep. So what does this number represent? That represents the A value. What does this number represent? The B value. And then we had to do t over 2.8 for that every 2.8 months. Okay, so I'm going to go ahead. Oops. I'm going to carefully type it in. We're going to start with 89,000 parentheses 0.944. And then I got to raise it, right? I got to raise it, but there's got to be a what? A little fraction. So I got to do a t, and I got to do what? 2.8. I think I got it. 0.944 t over 2.8, 89,000. Voila. Okay? So I'm going to do one more. I'm not going to take as many notes on this one. Okay? I'm not going to take as many notes on this one. We're just going to do a few more just so you guys have the idea of what to do. Okay? Holy cow. We've got a carbon-14 element which is losing what? 1/10. Now, guys, if it's losing 1/10, what is it keeping? It's keeping what? 9/10. So if it's losing 1/10, it's keeping 9/10. Every how many years? 871 years. And what are we starting with? Initial mass of what? Initial mass of 960. So what are we starting with, everybody? What's our initial amount that I'm going to write in right here? 960. Very good. I'll put 960. Now, if it's losing 1/10, that means it still has to keep what? 9/10. Because you're losing 1/10, it keeps 9/10. So I got to put what? 9 over 10. Now, if you wanted to, could you put the decimal equivalent 0.9 if you wanted to? Sure. But it's not happening every single year. It's happening every what? 871 years. So I got to put t over 871, just like that. So that's what I'm going to try to carefully type in. So I got 960. Okay, that's what we start with, right? That's our initial mass. Then I got to do 9 divided by 10. Since we're losing 1/10, we're keeping 9/10. So where would students mess up on this one? They would take the 1/10 and they put the 1/10 right there. And then we have to do what? Raise it to the power of, we're going to put t. Now why do I have to use the letter t? Because this says m of t. And I got to type in 871 years. Dadgummit, can't we get a growth one? Everything's decaying. Okay, now, everything's decaying. So Tallulah, that's a fun name, is an ecologist who studies change in penguin population. I like penguins. All right, who doesn't like penguins, right? If you don't like penguins, there's something wrong with you. Okay, there's something wrong with you if you don't like penguins. All right, she observed the population decays by a factor of. Now, hey guys, this one right here, it tells us, literally tells us our what? Our decay factor. We're not losing 8/9. What are we keeping? We're keeping 8/9. Every what? Every 4 months. And what are we starting with? 27,000. All right, so here's all you got to do. What are we starting with? 27,000. Okay. Parentheses, what fraction am I going to use? 8 over 9. Now, why am I using 8 over 9? Because they literally tell us the decay factor is 8 over 9. And then it's not every single month, it's every 4 months. So I got to raise it to the power of, and I got to do a fraction, and I got to put t over the number 4. Okay, I'm tired of losing stuff. So by the way, let me do this one. Let's say for example, it didn't lose something. What if it gained something, okay? So this is the last thing I'm going to do. I'm going to cross off losing and I'm just going to make up my own dadgum one because I'm tired of doing these. We're going to gain 10%, okay? So let's say we were gaining it, which we're not, but let's say we were. What would we do on this function? What's our initial value? 960, all right? And if it gained 10%, what would be our growth factor? What do you guys think? If we start with what, 960? If we gained 10%, what do we already have? We already have a 100%. That means we're at what, 110%. So what would be our factor? 1.10. So if you gain something, you got to add it to 100%. And then you still have to do what? T over that 871. So this is if we cross off the loses and you put and it somehow it gains something. Okay, so just be aware of that. If it's gaining a percentage, what do you got to do? You got to add it to a 100% and then change that to a what? Change that to a decimal to put right there. So that's all I'm doing for this video. If you guys can't get hundreds on this, then, well, I don't know what to say. Just keep working hard, all right? You have a good day.